is Julia, and welcome to the Great Physics Baking Show.
And I'm Connor. Today, our contestants will be competing in the Technical Baking Challenge of American Biscuits.
On your mark, get set, go!
Our first team of the day is Ashley and Grace, who are making their biscuits using a classic approach.
So, what is the secret to a good American biscuit?
Well, the secret is baking powder.
When the baking powder reacts with the liquids and being put in the oven, it produces carbon dioxide, which is what makes the biscuits rise.
So how exactly does that work?
Well, let's see.
Baking powder is made primarily of three compounds: sodium bicarbonate, a base, and sodium aluminum sulfate and monocalcium phosphates. Each type of atom contains a unique number of electrons. In order for atoms to be stable, their electrons need to fill up electron shells that exist in every atom. In order to satisfy the need for shells to be filled up, the electrons in the outermost shells of atoms may combine with other atoms that have the right number of electrons.
Electrons on the outer shell matter because they are the electrons that come closest into contact with other atoms, and they are also furthest away from the nucleus of their own atom, which means that they have the least attraction to it. For a chemical reaction to occur, it needs to be introduced to activation energy from an added substance or a new surrounding. In the case of baking powder, a chemical reaction is first activated between sodium bicarbonate and monocalcium phosphate when a liquid, in this case milk, is added to the mixture. This causes a chemical change in which the atoms in the two compounds are attracted to each other and form several new compounds, one of which being carbon dioxide.
The same thing happens between sodium bicarbonate and sodium aluminum sulfate after the batter is put into the oven. When the batter reaches a certain internal temperature after being in the oven for a few minutes, a chemical reaction occurs between these two compounds, which, like the first time, also yields carbon dioxide. The large number of carbon dioxide gas bubbles that are formed during the chemical reactions are what causes the dough to rise.
The other team competing for the next Great Physics Baker is Christian and Jay, who seem to have taken a slightly messier path to prepare their biscuit dough for the oven.
So, Jay and Christian, how does an oven work?
Well, let me tell you.
In order for our dough to rise, it first has to reach a certain temperature in the oven. This can be explained by the first law of thermodynamics. Change in U equals Q plus W, where U is internal energy, Q is the temperature difference between the object and its surroundings, and W is work done.
In order to make biscuits, the oven needs to be 425 degrees Fahrenheit, which is much greater than the original temperature of the biscuit batter. After the dough is placed into the oven, there is approximately zero work done because there is no displacement. However, there is a positive change in U because the original temperature of the surrounding is greater than the original temperature of the dough. Therefore, the change in U must be positive. Because of this, the dough is able to reach the right temperature so that the chemical reaction between the compounds and the baking powder can take place.
Time is up and Judge Julia is ready to taste.
This is Ashley and Grace's, and this is Jay and Christian's biscuit.
Will the lack of rise in Jay and Christian's biscuits cost them the competition?
The results have come in. Congratulations to Grace and Ashley for their light and airy biscuits.
How do you feel about your performance in the competition?
I'm upset. We trained a long time for this. We did our best. There's nothing else to say.
What do you think could have helped your performance today?
The baking powder.
How do you think you can come back better if you get a chance in the future?
Baking powder.
Continue to cook more.